We know that water, especially in its liquid form, is an important molecule needed to sustain life on planet Earth. But just as there was a time when there was no life on our planet, it is also theorized there was a time when water did not exist on our planet as well. One of the main points to support this is the evidence we have of Earth's early temperatures, which we calculate to exceed 100 degrees Celsius. Meaning if liquid water was around, it would have boiled into gas and have been lost into space. The most widely supported theory of how our planet obtained water describes that water was delivered to our planet from large colliding asteroids. In its early formation, and for a few 100 million years after, Earth received more frequent hits from large asteroids. Much more frequent than we see now, thankfully. After surface temperatures cooled, and considering the position of the Earth relative to the Sun, any liquid water received from larger asteroids could be housed on the planet because it could exist in a liquid state. We know from the previous video that hydrogen bonds are very present in the liquid state of water, which means it can hold more heat before phase changing, making it easier to retain on the planet and not be vaporized. The gravitational pull due to the size of the planet also plays a factor with holding onto the liquid water, which we currently see now as our oceans, lakes, and rivers are contained to the surface. So we have water on Earth, but what about Mars? While there is evidence that there was water on Mars, it is likely all gone due to the chemistry of the sediment on Mars reacting with the water via hydration reactions, combining with the available water and using it up in the process. Earth's sediment and mineral composition is different from Mars, which resulted in much less water being lost due to these types of reactions. Our planet, and many others out there in the universe, exist in what we call the Goldilocks zone. Like the porridge given to the three bears in the Goldilocks story, some planets are too hot for liquid water, some are too cold for liquid water, and some are just right. If a planet is too close to a star, the temperature will be too great for water to exist as a liquid, and it will be vaporized into a gas. If a planet is too far away from a star and has water, it will exist as a solid by freezing into ice. But if a planet is just right in terms of distance from a star to where the temperature can exist between 0 and 100 degrees Celsius, the liquid state of water can exist, which is also impacted by the size of the planet, influencing the gravitational pull and atmospheric pressure. All life that we know of is based on leveraging water in a liquid state. Based on this data, and considering that there are many other planets out there that exist within this Goldilocks zone with their closest star, it's not unreasonable to think that there could be other water-based life forms out there, somewhere, reproducing and evolving just as we do.